Hi everyone, for the last video in this series, we're going to look at some examples. Finding composition of functions. Let's say the given function is f of x is square root of x and g of x is square root of 2 minus x. Now there are four different compositions that can be formed. Two that we have already seen, namely f of g and g of f. However, there is nothing stopping us from asking something like, what happens if I compose this function f with itself, namely f of f? Or what happens if I compose the function g with itself? So this would be f of g of x, namely it would be f applied to square root of 2 minus x, which makes it the square root of the square root of 2 minus x, or the fourth root of 2 minus x. G of f implies that I evaluate f first. F by definition is square root of x. So when square root of x is applied to g, this becomes the square root of 2 minus square root of x. So you can see these are two quite very different functions. F of f is going to be f of x. This is going to be f of square root of x, which would be square root of x, or the fourth root of x. Similarly, g of g is g of x, which would be g of the square root of 2 minus x. So g applied to this would give me a square root of 2 minus whatever is the input, which is square root of 2 minus x. So in this case, as you can see, all of these four functions, they come out to be vastly different kind of functions, right? Now, as a bonus exercise, what you can do is for the above function, for f of g, g of f, f of f, and g of g above, you can try to find the domains of each of them. Okay, one last example is the reverse process is recognizing the functions that can be used to find create a function. For example, it says, given that some function capital F of x is the fourth root of x plus 9, and it says find functions g and h such that capital F is g of h. So this is reverse in the sense that you are given the composed function and you're asked to find what are the small bits which make this function. Right, so it's kind of like if you were going through transformation, how you would plot this function, right? So one way to think about this is you would go from x to x plus 9 and then you would go to fourth root of x plus 9. So you would want g of h of x to give you g of x plus 9, and that implicitly tells you that h of x then should equal x plus 9. And then you want g of x plus 9 to equal the fourth root of x plus 9, and this together tells you that the function g must be the fourth root function. Because remember, these are placeholders, so that if g of x is the fourth root of x, then g of x plus 9 would be the fourth root of x plus 9. Okay, now this brings us to the end of manipulation of functions, of function transformations, and function compositions.